Alright, welcome to worksheet number 6. Worksheet 6, product rule. If you have a function, we'll call it y, and it is made up of a product of two little functions, f and g. This is the generic look. To find the derivative, you would multiply the derivative of f times g and then add that to f times the derivative of g. So, in the next page, we're going to try an example. Here's example 1. You could just observe this. I shall give you a function, x to the 4th, times some other function, x cubed plus 2x plus 17. So certainly we could expand all this and then find the derivative, or we can apply the product rule. Before we start, I'm going to just note that this, we'll nickname that the f function, and this whole thing on the right, the g function. When you find the derivative, you do the derivative of the f function, which is 4x cubed, multiplied by the normal g function, x cubed, just the same way you see it, x cubed plus 2x plus 17. And then add that to the normal f function, which is x to the 4th, and then multiply by the derivative of the g function, 3x squared plus 2x, plus 2, plus 0. The derivative of 17 is 0. So those parentheses were unnecessary. That's how that looks. The next page, I'm going to do a problem with you guys so you can get your worksheet ready while I yap here. It's worksheet number 6, problem number 5. We'll do that together. Problem number 5, they give you they call it a function. I'll still write it like y equals the quantity of 5x to the 5th plus 5. That's our so-called f function, times negative 2x to the 5th minus 3. That will be our g function. To help us out there, I'll put a little f and g, and then here in yellow, I'm going to remind myself that to find the derivative, what you do is the derivative of f times g, add that to f times the derivative of g. I'll remind you further, derivative of f times g, f times the derivative of g, again in yellow. Now we are ready for, what is the derivative of f? That would be 25x to the 4th plus 0 technically, so we're done. This is normal g, so I just take normal g, negative 2x to the 5th minus 3. Here I have normal f, so I write normal f, 5x to the 5th plus 5, and then now the derivative of g, that says negative 10x to the 4th plus 0. So for today's purposes, we're done. That's what we're looking for. Let's use this maybe. Some books or assessments make you simplify this. They make you expand this by distributing, expand this, and then combine all like terms, pardon me. We're going to say we're done. That's how you do worksheet number 5, problem number 6.